kind of guess and check until you find something. The method I use, it kind of avoids all the guessing and checking. It just kind of, you find the first factors right away. So I'll show you guys that. So 4 times negative 5 is a negative 20x squared. Now and then on the bottom I want a negative 8x. So I want to multiply to negative 20 but add to negative 8.
How do you get the negative 20x squared out of that?
It's these two multiplied together. So on something like this, what do we get then for negative 10, positive 2x? And last time I'm going to split that middle term up. Now we're ready to factor. So when I go to factor this, I factor 2 terms at a time because that's our grouping factoring. So out of these 2, I can take out a 2x. I'm left with 2x minus 5. Out of the second 2, I can only take out a 1. There's nothing common, so I'm going to put like a 1 as a placeholder. And so now this is factored. I just have to rewrite it one more time. So these would be the 2 factors that would work. Those are the only 2 that work. Now, had you not gone about it this method, basically when I learned this as a high school student, I wasn't taught this method, and I just learned that I had to keep guessing and checking until I found the combination that worked. Someone as a teacher taught me how to do it this method, so I started doing it that way, but not everyone does it that way. So I'm not trying to say it's the only way. Again, same thing for like letter B here. You could just start making lists of factors of 2 and 6, 3 and 4, 1 and 12, like different combinations that work for 12. Then you have to do the same thing for 10, and then you have to FOIL. Yep.
Where does the 2x go? That's like kind of the
So what we have, like, so this one.
Yeah.
So what we did was we took out the common factor. So that was the 2x minus 5, and then the leftover was 2x plus 1. So that just came down here. So like the same thing came out that was common. I can pull that common factor out, and then I have my leftovers. Now, if you guys hate this method, like I said, some of you guys may be just seeing this for the first time. I'm pretty sure like Stone probably hasn't seen it because I know I didn't teach in algebra. But if you don't like that method, you don't have to use it. So like in letter B, if I'm doing 12x squared minus 23x plus 10, again, what I'd have to do is just set up a whole bunch of little FOIL problems and basically FOIL until I get it to work. So I'd have to do like 2x and 6x and 5 and 10. And I have to keep doing combinations until I found one that worked. Not 5 and 10, sorry, 5 and 2. Like to get those parts. Otherwise, you guys could try this and see if it works for you. And again, I don't usually show another method until I feel like it works for more students than just like 2. Like I don't like choose it just to be difficult. So what I do here is these first 2 I'm going to multiply. 120x squared, which is a pretty big number. So that one's getting kind of iffy in terms of like wanting to do this method. So those are pretty big numbers. And then the bottom, a negative 23x. I want to find a number that multiplies to 120, or set of numbers, but adds to a negative 23. And so sometimes it's a matter of me like kind of writing some down over here. Sometimes I have to grab my calculator because 120 has some pretty big numbers. If I do 20 and 6, I'm looking for factors that add to give me 23. And I think I found it, 15 and 8. So 15 times 8 gives me 120, but 15 plus 8 gives me 23. So in order to get my negative here, but my positive here, they can both be negative. So I'm going to use that to split this middle term up. So minus 15x minus 8x. Be careful with my signs. all I do is I change that middle term. I make it a new term that means the same thing. Out of those first two, I can take out a 3x. Out of the next two, I can take out a -2. Because I want that term to match, so if I take out a -2, then this is a +4, and then this is a -5. And so I'm left with 4x minus 5, and then 3x minus 2. And so that's our factored version of the original. Yeah.
How does the 5 turn negative?
Because we pulled out, good question. We pulled out that negative. So were you okay with it being negative here?
Yeah.
Then here, I knew I wanted this to match that. So this was a -8. So I pulled out a -2 to make that a +4. Because I knew I wanted them to match.
Okay.
So then 10 divided by a -2 gave me that -5. So like there's all those little detail lists that kind of are important to make sure those match. Would it be helpful just to practice that for a little bit? Are we okay? Was it? We're okay? Okay, you're feeling better about it? Like I said, I think Stone's one of the only ones of you who I had like through, maybe some of you for Algebra 2, and not Algebra 1, so maybe some of you haven't seen this before. It's just, like I said, it's just something I came across over time and I liked it and I stuck with it. But so what we're doing today is we're going to solve inequalities, but we're going to need to know factoring in order to solve those inequalities because we need to find some really important points. Because solving inequalities, when you guys learned about them like back in algebra, you were just able to solve like normal. You just had to remember a few extra things. We graphed them. It was pretty easy to do. But solving these like quadratic or polynomial inequalities are a little more confusing. So what we're going to do is once we add like an exponent to these, the solutions are not as obvious as just solving it and like setting it greater than or less than 0 or whatever it happens to be. So what we're going to do is this is called the test point method. And I've heard them called like critical points. So we're going to find basically the zeros of the function. We're going to call those critical points. The zeros of the function are essentially what you guys have been finding when you're solving these. So like in that problem where it was already factored for us and we found all the zeros, that's when it equals 0. We're looking for those. We're going to find those zeros of the function. So set the equation equal to 0. And then we're going to test. So what we're going to do is we're going to test numbers in between those values. So we're going to check to see where the equation works and where it doesn't work. So we're going to check those critical points to write our final equal. Okay, don't just sneak up behind me, jeez. I mean, on edge here. Alright, so we'll start with this first one. So when I tell you guys to find the zeros of the function, essentially I just want you guys to solve this like we were solving for x, but we would solve using factoring because it's a square. So I need to make it equal 0 first. So I'm going to move that 3 over to begin with. So essentially we're solving this as if it was an equation. So So I'm trying to figure out where the zeros are of this function. So where does it equal 0? So I'm going to factor this like I did before. So the x squared ones are really nice to do. You don't have to do the little x thing for it. So I already know it has to be x times x. What am I trying to multiply to get? Multiply to negative 27, so add to negative 6, so it's going to be what? Negative 9, positive 3?
Sorry, 9. Yeah.
Yeah, no, yeah, yeah. So if I were to solve those would be our, what we're going to call our critical points. They're really important points in this example. So x is 9 and x is negative 3. These are not the solutions. These are the critical points. These are the points that basically make this equal 0. But I don't want it to equal 0. I want it to be greater than 0. So it's not as obvious as just saying x is greater than 9 and x is like greater than negative 3. That's not going to be the answer. So what we're going to do is put this like on a number line. So my critical points are what's going to go on the number line. They're going to decide where I test. So negative 3 is smaller than 9, so I'm going to put it over here. And I'm going to test these, they said, like this test point method. I'm going to kind of use these as my 3 dividing lines. And I'm going to see if this works or doesn't work. I want it to be greater than 0 when I test these different points. So I want to pick something smaller than this in the middle and then something bigger. So tell me something that's smaller than negative 3. Negative 4, he got crazy, negative 4. So we're testing x is negative 4. So we're going to check and see if it works. Now I can put it back in this original equation. I think it's a lot easier to put it back here. Cash, could you stay? This is a really important part.
Okay.
Like, wait till we're done with an example and you feel comfortable with it. So our negative 4. Negative 4 minus 9, what is that going to be? You don't even need to know if it's a negative or what the size of the number is, a negative or positive. Negative 4 minus 9. It's negative, right? And I'm multiplying that by a negative 4 plus 3. What's negative 4 plus 3 going to be? Negative or positive? Negative. So if I multiply two negatives together, what's going to happen? It's going to be positive. Is that what I want here? Greater than 0. Yes, that's what I want. I want it to be positive. So this is going to be positive. So that means it works here. So happy face works. We want it to work. So that means all the points on this side of negative 3 are going to work. So I'm going to kind of show that by a graph. I want it to be greater than 0, so that makes sense. Again, I don't need to know the actual numbers. I just want it to be bigger than 0. What's a number I can test between these two? 0. I would always pick 0 when you can. It's very easy to test. So I'm going to test 0. So again, I don't care as much about the number itself. I care about just positive or negative. 0 minus 9, negative. 0 plus 3, positive. If I multiply a negative and a positive together, what happens? It's negative. That's not what I'm looking for. So this middle, it's not going to work. So it doesn't exist between those two. So anything you chose between those two wouldn't work. Now bigger than 9. 10. Okay, so try 10. 10 minus 9, positive. 10 plus 3, positive. So it works over here. So my inequality has now been able, now I'm going to be able to say where do my x values work? Smaller than negative 3, but bigger than positive 9. So I would write that then as an inequality. We call this an OR inequality because it's going out to both sides. So x is less than negative 3, or x is greater than 9. Now again, they're not equal to because there's no equal to line in this problem. If there was the equal to line, then we want to include that as well. So like I said, today and yesterday do connect in the way that we're doing some factoring. I don't think it's a bad thing that we're kind of doing those and we'll lump them together tomorrow then. Well, let me show you guys the next one. Yeah, if you think you can, yeah. So let's look at example 2 here. Again, I wanted to have it equal 0 to begin with. So move everything over to one side. I would move it over by the 2x squared. So I'm going to move this over and that. I'm going to warn you guys, this one doesn't need to be very difficult. Does anyone see what you can do to make this a little bit easier? Yeah, let's simplify. Let's take that 2 out of there. Divide a 2 out because all of them are divisible by 2. So let's factor that out to begin with, and it's going to make this a lot easier to factor. Technically, you can just divide it out of the whole thing. I'm just going to put it on the outside so you guys can see it. I prefer to factor like this if I have my choice because I think it's just easier, even though that other method is doable. It just is a lot easier to factor this way. Because I already know it has to be x and x. Multiply to get 8, add to get -6. -4, -2. And remember, we're not really solving this right now, we're just finding those important critical points, so those points that tell me what to put on my number line. So our critical points are going to be 4 and 2, yeah. Now this time, are they part of our solution? Yeah, they are, because we have that equal to line, so we can include them as part of my answer. So 2 and 4 would work, it's just there's also other numbers that can go along with it. But now just notice this time as well, the inequality is flipped. So just be careful as you're doing this. Now we want it to be less than 0, so we actually want it to be negative. So pick something smaller. I usually choose 0 if I can. If you pick 1, it'll be fine as well. So I'm testing 0. 0 minus 4 is -4. 0 minus 2 is negative. 2 negatives are going to make a positive, so it doesn't work over here. Yes?
So do you just forget about that original, or the 2 you took out of it?
Well, the 2 multiplying it by 2 is not going to change anything.
Okay.
So you can use it, you can get rid of it, however. Yeah, the times 2 isn't going to change the signs or anything, so. All right, in between 2 and 4, I don't have a lot of options unless you want to work with decimals. 3. So we're going to test 3. 3 minus 4 is a -1, so a negative. 3 minus 2 is a +1, so it's a positive. So it's definitely going between these two. And then something bigger. And you're going to start to notice a pattern with these that this kind of does end up. So this is positive, positive, so that doesn't work. So we want it to be negative. So this time, we're in between 2 and 4. And the way we write this would be like an and compound inequality. So I prefer to write it this way, where it goes from 2 to 4. Now if you wrote x is you know, less than or equal to 4, but greater than or equal to 2, it'd be okay as well. I'm gonna try one more before we take a little break here. We're home a very long time for a break, but. Alright, this one's already set greater than 0, but this is the tougher type of factoring because it has the number in the front. So again, you can choose to guess and check until you make it work, or you can try this other method that I showed you guys. Again, if you're still getting used to it, I multiply that first and last term together, and then the bottom number, or that middle number just goes on the bottom. It just tells me what I'm multiplying to get and what I'm adding to get. So what are your factors there? Yeah, what you get, Sawyer?
You do
5 and 8, yeah. 5 times 8 gives me 40, but 5 plus 8 gives me 13. And now if you haven't noticed or haven't done these many times before, it doesn't matter whichever one you put first. It doesn't, do you guys have a preference? 8. So obviously you have a preference. So 8 and 5. I usually put the bigger one first too, but it's up to you. It'll work either way. Again, we're factoring this to find those critical points. So I can take out a 4x. I can take out a 5 here. My one critical point is a nice one, it's -2. My other one's a decimal, and so that's not great, but at the same time it's not impossible either, so don't let that freak you out too much. It's just going to be our test point's going to be a little bit weird on this one. So -2 and then a -5 over 4, so -1.25 is my other one, which is going to be a little bit dicey when we do that. So. You could call it -5/4 as well, whatever you prefer. Now looking back at this problem, notice this time I want it to be greater than 0, so I'm looking for positive outcomes. So I want it to be positive when it finishes. So pick something smaller, so -3. Oops, -3. So that's going to be a -1, and then this one's going to be a little bit more of a pain. So -3 times 4 is a -12. Obviously, -12 is bigger than -5, so that's going to be, or +5, that's going to be a negative. So this become a positive, so we'll go this way. So that works. Positive is what we're looking for. Now, you might be able to do a little bit of kind of guessing. The middle's probably, you're going to notice there's patterns here. Typically the middle doesn't, like either outsides work or the middle works. So maybe I'm just going to check this other side. So let's check 0 over here. This will be +2. This will be +5. So that also works. You could go ahead and try that middle. It's not going to all work. So we're probably pretty safe to say x has to be less than -2 or x is greater than 1.25 or -5/4. All right, we're gonna do a couple more in a minute here. Let me get this part online. Like I said, I've been having issues with